Invite our next speaker for the session, that's Mr. Piyush Kumar. Piyush currently is the VP Data Engineering at 𝗕𝗏 with over a decade of experience in building large-scale, high-performance systems. He has been part of the e-commerce industry throughout his career in various technology leadership roles across different domains like comparison, shopping, travel, marketplace, and had managed team in website operations, security operations, and big data. At 𝗕𝗏, Piyush is leading a key strategic initiative in data services, products for the personalization, customer segmentation, and effective customer engagement.
I'm sure in audience there would be many, I'm assuming there would be many 𝗕𝗏 customers sitting over there. But just to give a brief about a context about the group overall, right? So 𝗕𝗏 is a 3-brand story with 𝗕𝗏, Wysetek, and 𝗕𝗏, right? So and to cover and then stitch to how behind the scenes, right? So various stuff is stitched, and I'm going to cover mostly one part which is given to me, which is industry is moving from big data to fast data plus, right? So that is what I'm going to cover through my session, and going to talk about feature store and other things as part of my presentation as well. So just to quickly talk about, right, so the group I spoke about, right? So we have travel use cases starting from air ticketing, hotel, holiday packages, etc., which has been our core for many years now. And then the ground transportation part of it, which is bus ticketing, bus hire, rail bookings, etc. To top it, right, so 𝗕𝗏 is positioned like a super app of travel, wherein, right, so we are adding not just covering the transportation or accommodation needs of a user, we are also covering again a gamut of services attached to it as well, right? So that falls into the other bucket of ancillary use cases, starting from travel insurance to travel credit through trip money, which we are powering in book now, pay later kind of services, and then Forex and other pieces. And then the new demand segments which we are adding through MyBiz, which is our corporate travel solution for SMEs, and then Quest to Travel, which have been a greater story for large enterprises as well. And then B2B2C through my partner, wherein so we are powering the platform and the services required through travel agents to fulfill those things as well. And then so there are, if you go to Amazon Pay, etc., right? So we are powering the API, affiliate API model to them, right? The interfaces of the affiliate partner, and then behind the scenes, right? So the supply and other services are stitched together through our platform itself. So that's a platform play which is going across the board, and that's what I said, right? So we are positioned like a true travel super app for India and across, right? So this is just to quickly talk about so throughout the day we have listened the key things, right, in terms of, right, not just focusing on data quality, this, that, all those kind of things, but so you don't require much of the things, right, or so PhD in machine learning, etc., to consume a lot of it, right? So the key here with the point I wanted to make is, right, so the key overall is to drive data-driven decisions all across, and there are many ways to do it, and I'm going to cover some part of it, and happy to cover in Q&A part of it as well, right? So this is how the data journey for us started, right? So it's a typical, for any organization, you start with hindsight, right? So solving some smaller use cases related to customer segmentation, matching offers, etc., and then moving on to why part of it, what part of it in terms of fraud detection, payment gateway switcher, persuasions, so the insights which you generate are then used in terms of persuasions, content, along with the travel listings which you see on website, to the harder part of it, right? So where you are trying to truly predict, okay, this user is going to buy these recommended products, etc. So the ranking, pricing. In features like fare log, we are truly predicting if the fare is going to rise, because like so there like so it is very similar to insurance, where you want to minimize the risk of the product which you are trying to bake in with that feature itself, right? So those are the things, and then personalization is something which we are deeply working on to improve. So that's the data journey we have. I'm going to quickly talk about like so the behind the stuff, right? What tech stack, etc., so that you relate to some of the problems I'm going to talk about primarily on the fast data layer side of it. So typical data capture through some of the internal services which we have curated, right? So PDD, Kafka, we leverage primarily to ingest data on our data lake, which is primarily data storage. We are on AWS, we leverage Databricks and AWS analytics stack primarily. And then there are services on catalog side of it, which is again built in-house, which we call it Columbus for our data discovery, data cataloging, and feature cataloging side of it. And then the unified platform, compute platform, which we call Feature Store internally, which is not just like so leveraged for machine learning use cases, because in typical organization, Feature Store is primarily focused only on machine learning use cases and implementation of it. In our case, right, so everything has been modeled like a feature, and that is helping us churn, build, curate, aggregate, and lot many things just by that notion itself, right? So data flow now powers experiences. People talked about throughout the day, right? The feedback loop, experimentation, and lot many things. So and that's what is at play here, wherein like so we tailor good amount of customer experiences through recommendations, engagement loops, personalization across content, search, ranking, pricing, in-location engagement use cases. And then, as I said, right, so we are positioned like a super app of travel, right? So when a user is on our platform, he or she is primarily browsing through different funnels, right? So when you are into flights, your experiences, or like, so you are primarily like doing your searches for flight listing, going into details, looking at those kind of things. At the back, right, we are stitching those your journeys as trip graph, wherein like so vertex represents the destination of travel, and then edge represents the product searched or booked by that user itself. Within that trip graph, we figure out, okay, what are the missing edges? Using those missing edges, we create, that becomes the opportunity set. That opportunity set is then ranked, filtered, etc., primarily to generate the right recommendations back to you, right? So those are the things behind the scenes which we curate. Now I'm going to talk about the key challenges, and that is primarily in terms of, right, so big data has been there for ages now, and companies like FANG companies, primarily like Google, etc., have been doing it for many decades primarily, right? So, and it was the masses which, the adoption of, with the term big data and rest of the things, the proliferation happened much later, but these companies have been leveraging the stack for many years in their internal platforms, etc., right? So the typical origin of big data is like so with batch processing, right? It is the workloads which you run are very batch oriented, right? And that's where the stream processing evolved as well, wherein like so streaming has taken a shape of micro batching, etc. There are many systems which do event by event processing, and I'm going to cover some challenges with both of them. The key part here is like, so you ingest and process continuously, so that it is potentially infinite streams which you are continue to process ever, right? It is not, it's a long running jobs which are continuous, right? And that's where the challenges kick in. And across the board, right, so people have been using Kafka as a backplane for fast data processing, but I'm sure like so people, like so Fivetran folk was also alluding to some of the challenges related to Kafka as a layer itself, right, with their offset management, checkpointing, and many other things. The key part is it is always on, and hence the challenge with respect to resiliency, availability, dynamic scalability of the workloads, the number of event streams which are pumped onto this platform. The key learning which have been for us while building some of the stuff which I'm going to talk in next slides is to take a clue primarily from the microservices architecture which have been there for again decades, right? So the key capabilities which you want to probably focus on is to improve the overall latency. So the moment a user, for example, think about like some McMatrip users or 𝗕𝗶𝗴 etc. as in form of IoT itself, right? So just an analogy, right? So people are using your apps, they are generating some data, you need to take some decisions in terms of customer experience back to the customer itself in real time, right? And hence, whatever decisions which you are taking at the back, for example, like so, just a smaller example of propensity to buy in this session for a user itself, right? You cannot rely only on your batch systems to provide those propensity numbers, etc. Because like so here is a user who is doing some searches right now coming in from any channel. He may have initiated their searches on Google, Meta, or any other platform and just landing onto your platform. You need to do the right thing, right pricing, right product selection, etc. for them, right? So you can't just rely on the historical data or the features which you have been curated for that particular user. You need to do it in really with low latency, and hence here the focus is to how soon within millisecond latency, how from the event generation to the consumption, right? So the consumption is, right, for example, if I just propensity to buy itself, right, the inference from my machine learning model, the latency has to be really, really low, right? And then it has to be predictable. You can't have like, so for example, just saying, okay, I have across my design or architecture, I have put back pressure handling and all those kind of things, because ultimately, like, so even if you have taken those kind of things, the user may have dropped off from your session, right, from your app itself. There is no use of predicting when the user has left your platform, right? So you need to ensure, like, so the processing pipelines, etc. are predictable, right? And then unified interface across you can't put like so n number of stream processors all across. And that has been the state earlier for us as well, right? People who are using Kafka streams, Spark, structured streaming, Flink, everything, right? The key part here is, right, so you need a unified way of expressing how you want to compute and run your stream processors overall, right? Then fault tolerance and recovery part of it is critical as any other system itself. But here, because there are decisions which are relying on the input data which you are receiving all across, right? So, and the other key part is the flexibility of operation aggregations and processing logics. So, because now for example, in our use case, you need to keep a state of user and its stateful operation, right? It's not just like reading a stream of data from event from Kafka and then writing into another Kafka topic, processing kind of stuff never works in the use cases which I'm speaking about, right? So more or less you need to enable it, the low latency processing in the streaming part of it with stateful operations overall, right? And yeah, so when we started going back to our journey itself, right? So ours was like very pipeline jungles kind of a thing, right? So for every use case, we were trying to pull in data from sources, writing their compute jobs, creating features, and that's how, like, so here, like, for example, 3 use cases I have written, but similarly, like, so we had like n number of use cases across the organization where you are bringing a similar kind of processing for similar features, but like, so for example, a different pod team would have given a different use case to work on. They generated a similar features into a different pipeline altogether. So as I said, right, so we solved it through feature store across the board, not just specific to machine learning part of it, even the customer segmentation part of it, And the communication platform, the marketing team uses our communication platform sitting, like the CDP is built on top of Feature Store itself. So here you are, so users, which is data engineers, data scientists, or software engineers, are defining features as some feature definitions itself. Yeah, very similar to any software which can be defined like input, process, output. You have now abstracted your source, compute, and sync in your world, right? And what this has led us, like, so primarily is, so now you have the raw data, event signals, you have curated on top of it, again using the same unified compute platform, which is Feature Store. You are all in the same system, you are generating insights, then taking out actions on top of it, which is your recommendations, etc. And then the complete measurement platform as well, right? Wherein the experiments like A/B experiments, multi-arm banded algorithm, contextual multi-arm banded algorithms, etc. are generating those things as features. KPIs are also measured like features, etc. So one unified platform enables you to think and work on those kind of things. So typical data flow is, right, so you have data capture, you enable quality measures, etc. You enrich, curate into a different data model. I spoke about like the graph of trip journeys, then the intent computation, sessionization, then computation of your opportunities, and then the whole stack is then generating the experiences back to the user through different platform. Target is the communication platform I was speaking to. In the interest of time, probably I'll skip the use cases here, but just to give a glimpse of like how the whole piece is structured is. So in the center, if you see rate FS config, which is a feature catalog, wherein users are defining the features. The rest of the things like the scheduling part of it, which cluster, how many worker nodes, etc., is abstracted by the end customers. End customers, which are like data engineers, data scientists, etc., are focusing only on defining the features itself, the optimizations, what cluster sizes, when to schedule, because now I have good amount of metadata, which feature groups are dependent on which features, feature groups or data sets. The complete lineage is created internally by us. We are able to optimize a lot of workloads internally and then run our jobs on this platform. On the serving API side of it, right, BoulderDB is our in-house data store where we have leveraged RocksDB and then created sharding logics, cluster management, etc. on top of it to serve the billions of keys out of it. And then obviously we are leveraging Redis and Aerospike as well along with the same. Again, like, so as I said, right, so everything has been modeled like a feature all across. These are some type of features. You have batch, real-time API. API is like, so we also enable MVL based, like, so expression, where you can just in runtime based on the available data from your real-time API layer can be computed and like served as a data API to other services all across. BoulderDB I have already spoken about. Yeah. I really want to take some questions, so I'm going to leave it there itself. Just quickly talking about, as I said, right, so one single unified platform which is sitting on top of it. Then we have the orchestration layer on top of Feature Store, which we call it Experience Engine. And then you have the other consumers all across, like, so funnel, communication, content, and digital marketing sitting on top of it. Yeah. Yeah. Happy to really engage with the audience here. Thank you.
Thank you, sir. Quick questions.
Really looking for people to ask. Yeah. Go ahead, please.
Yeah, really interesting presentation. So just want to understand, when you say feature store, I think you are referring to a very non-traditional use case of a feature store. So is this like one centralized feature store across the organization, or you are just abstracting it and calling it one logical feature store?
No, not logical. Proper one unified feature store across the organization for both the brands. Here, the brands are 𝗕𝗏 and 𝗏𝗏. So logically separated across, like so, with all the legal compliance in terms of underlying delta storage would be on different S3 buckets mapped to different accounts, etc. But this is one unified feature store across the organization.
So in this case, I think you mentioned data engineers, data scientists, they keep on adding features to this, and you know, they become available to anybody in the organization.
Yeah, hence the reusability part of it, right? So otherwise, as I said, right, so we were, the story was pipeline jungles. You end up creating n number of pipelines all across, then you have other issues, right? Managing those pipelines, changing even a single KPI or logic all across. Think about the use case where I was saying, like, so last session by a user in hotels or some other logic, or maybe gross revenue minus selling, or any compute I need to make, right? So the logic need to be replicated all across different pipelines as well, right?
So one last part on the same line. So does it not lead to, you know, just exponential increase in the number of features, since I think you just have one feature store like in place?
No, so that absolutely, because like now you have those problems, but that's what the platform play is, right? So platforms are meant to build to solve scale problems, right? And platforms are only scalable things which you work on, build on. That's what I was referring to in terms of wherein we have our own scheduler, right? Which is figuring out, okay, how to optimize those workloads. We are not just in saying, right? So there is no user which is defining, okay, run this on M6G X large cluster, or this, do this, that, etc. Because if I leave it to the users, there will be a number of unoptimization and then cost management and other challenges which kicks in. So you need to, like, and platform play enables you to optimize those things. Otherwise, if it is going to be a pipeline play, it is unmanageable and unoptimized as well.
Sure, thanks.
Thank you.